Everybody, I'm Ray Brushart, and I'm with the Ohio LTAP Center, and which is located at the Ohio Department of Transportation in the Division of Planning, in the Office of Local Programs. And today we are making a video on how to properly conduct a curve study. And the main part that we're going to focus on in the curve study is how to properly determine the advisory speed for a curve. And this has all come about because we've been getting a lot of questions from our township trustees and county engineers who are participating in our township sign upgrade program. And they need to know what is the advisory speed of a curve so they can order the signs for that curve. And when I'm talking about the signs for a curve, here's a picture from our OMU TCD and the Ohio Manual of Uniform Traffic Control Devices. And it shows a specific sign here, the advisory speed plaque, which is sign W13-1P. And it's a very important sign, so it lets the drivers know what they should bring their speed down to as they traverse through the curve. And today I have Jennifer Jenkins here with me. She's our District 6 transportation engineer who specializes in these curve studies. She's done a lot of curve studies throughout her career, and we selected her as our expert for the day, and which she has earned very well. And so she's going to talk about the curve study in general.
Yeah.
And,
so today we're going to go out and do a curve study and to determine the advisory speed, because the placement of all our other signs are dependent on what our advisory speed is. So there's a couple different ways to do that, but today we're going to use the digital ball bank indicator, and we will show you how to mount this in the car, how to drive through the curve. It's important to maintain a steady speed and to get the readings from this to determine what the advisory speed should be and how to place the advanced warning signs, the chevrons, the large arrows based on that advisory speed. A couple important forms that we use is section 1200 of the TEM. There's directions on there about ball bank indicators, and it kind of outlines what we're going to go over today. And then another important go-to place is part 2 of the OMU TCD. That's the Ohio Manual of Uniform Traffic Control Devices. It has tables in there to help you decide which signs to use and where to place them. So we're doing this to address roadway departure crashes. Every 30 minutes there is a roadway fatality from a roadway departure crash in the U.S. So our goal with this program is to address roadway departure crashes and to keep cars on the road. And we're going to do that by illuminating our curves and drawing attention so that the cars will slow down.
that's right, because when you install these signs, it's been determined and studied that just by adding these curve signs to your curves, we can expect to reduce crashes by up to 25% for that curve.
That's
Just
right.
by simply installing signs. So we're going to a bang for our buck. It's a low-cost countermeasure.
Right, and ODOT is rolling out these systematic safety programs. Upgrading our curve signs is one of them, upgrading intersection signs, the rumble stripes, for example. So we're trying to address a lot of locations with low-cost countermeasures instead of just a couple individual spot locations where we're spending a lot of money.
That's right, and we've selected a curve down in Fayette County, Ohio on State Route 41, just north of Washington Courthouse. And so the next time you see us, we're going to be out in the field down on State Route 41. All right?
Sounds good.
So we'll see you out in the field.
Alright, the first thing we're going to do is install our digital ball bank indicator. So So we have a piece of Velcro on the bottom, and we're just gonna put it on the dashboard with another piece of Velcro. It comes with this cord, and it's so you can attach it to a computer, but we're not gonna use the computer today, but it's also the power cord. So you just plug the big end into the little end. And then this just plugs into your cigarette lighter. So we should have power now. So you want to make sure it's securely fastened to your dashboard. And then you need to level the meter initially. So this REL button is to re-level it. So when we push it, it should re-level to 0. And it bobbles around just because of the vibrations of the car. And once you have it leveled, you don't want to turn it off. You want to make sure you leave it on. And before you level it, you want to make sure everyone that's going to be in the car is in their seats. And once you level it, you don't want to switch seats. You want to keep everything nice and even. And you want to level it when your car is on a flat surface. So we are sitting on a concrete pad right now to level this. That's all there is to it. Alright, we're approaching our first curve study location, and I wanted to go over the the forms that I normally print off before I do the study. This first form is a map of the location, and I leave a blank spot to take notes of existing conditions. And since this location was identified because of the number of crashes that we've had, I reviewed the crash reports before we came out, and this is a summary of the types of crashes that we've had. Right here, this is the curve that we're going to study. This is where the majority of the crashes were occurring. And I just got on Google Maps and used the measuring tool and measured the length of the curve. So I measured the curve length at 450 feet. You can use Google Maps, the measuring tool in there to do that, or if you have a distance meter in your car, you can use that, or you can get a wheel and use that to measure the length of the curve. I also measured the distance to the next curve, which this is 895 feet, because 600 is the magic number. So if there's less than 600 feet between curves, you treat it as one location, but if there's more than 600 feet, then you treat it as multiple locations and you sign them separately. But if there's less than 600 feet, then it would be treated as one location and you would sign it together with a reverse curve sign. The second form is the curve study sheet. So what we're going to do is we're going to drive through this curve several times, and we're going to maintain a steady speed. And we'll want to go that speed several different times. So here's enough for 3 trials, and then we can take the average of that to determine our advisory speed. And then this third form is our curve sign order form. So this has all the different signs that we could apply to this curve and has places for quantities. And then in this spot down here, I normally make notes of what the actual recommendations are. And those are the 3 forms that I print off before we come. Alright, as we're approaching our first curve, I'll push this min-max button to start the meter. So I want to do that when we're on the straight section approaching the curve. And you want to maintain a steady speed. We're starting out by driving 35 miles per hour. So we want to maintain a steady speed and not have any jerky hand movements through the curve. We just want to go at a nice steady speed.
Okay. Got it at 35 exactly.
Alright, and try to stay in the center of the lane and avoid any bumps along the way. And then once we're on the straight section again, I'll press this min-max button to get our reading.
Okay.
Now you'll notice that curve already has some curve warning signs on it. This location was identified by FHWA, and it was based on the number of crashes, so not whether or not the signs were existing. But we're field reviewing all of these locations, and a lot of the standards have changed in the past couple revisions of the OMUTCD, so we want to make sure it's up to current standards. So now, once we pull over, I'll write our readings down in our curve study sheet. So this meter, it'll give you a negative number and a positive number, and that's whether it's a left curve or a right curve. So it measures the minimum and maximum readings left and right. So we want to take the highest number, the absolute value. So if it's negative 12.83, we'll take 12.83. But we want to get that's the minimum, so we want to get the maximum too. And it's 2.16. So we want to take the 12.83 reading. So we were driving 35 miles per hour, and that was our first trial. So right here we'll write 12.83. Alright, and now we'll drive through it the other way and do the same thing. So we're going to go through this first curve first and not push the button yet because we want the measurements for the second curve. Now that we're on the straight section, approaching the curve, I push the min-max button, so that starts our meter reading. Now if there was less than 600 feet between these two curves, we would have started before that first curve because we would sign it as one location.
Okay, 35 miles per hour on the button.
So again, we're maintaining a steady speed through the curve. Then once we get back on the tangent section, I push this min-max button to get our reading. So that run we were running southbound. So here I noted northbound and southbound. So each direction you put it in separate boxes. But we were going 35 miles per hour, and we got 14.29 and 3.59. So we're going to take the 14.29 reading and put it in this first column. For 35 miles per hour to be considered a safe speed, our reading should be below 12 degrees. So we'll run through this again and we'll knock it down 5 miles per hour. So we'll go through this curve at 30 miles per hour.
Found the culprit. Alright, let me slow down to 30. Okay, I'm at 30.
For that run, we got 8.29 and 2.23. So that was northbound at 30 miles per hour. What was the first number? I think it was 8.23. So for 30 miles per hour, to be considered a safe speed, our reading needs to be less than 14 degrees. If it's over 12, it's still safe, but if it's less than 14, then it needs to be less than 14. That's a little bit lower. So maybe this first reading was high because we had hit a bump or didn't go through the curve as smoothly as we could have. So we'll bump it back up to 35 and try that one more time. You'll notice this curve already has advanced curve signs with 35 mile per hour speed plaques. And the signs actually look pretty good, so we're just verifying that the right signs are out here. Alright, we reran this one at 35 miles per hour, and we got 10.68 and 4.39. So the 10.68 compared to the 14.29, we actually got a safe reading this time. So maybe we got this high reading due to the surface of the roadway, like bumps in the road or pothole, or maybe we hit something that threw our number off. So we'll run it again at 35, and maybe we'll throw this number out if it seems higher than the other two numbers.
Let's try it again at 35.
So northbound going 35 for our second trial, we got 12.53 and 1.36. So we'll take the 12.53 number.
Three times at each anyway, right?
Yeah.
So it was 12.83, and what was the first time?
12.83, 12.53 going northbound, and then southbound we had 14.29 and 10.68.
Alright, so here we go, 30.
That was southbound at 30. And we got 10.41 and 1.73. So we write down the higher number.
Was that the first time at 30?
Going southbound.
Yeah, this will be our second time at 30.
Correct. Going northbound.
Okay. It's definitely got some super elevation.
At 9.23, 3.40. Take the 9.23 reading. Alright, we just got back from the field and we have all our numbers here, and now I'm going to go through how to fill out the curve sign order form. I've already filled it out, but I just want to go through it step by step with you. So here is our curve study sheet that we filled out doing the ball bank study. So we need to determine what our recommended advisory speed is. So for this section, if it's less than or equal to 12 degrees, then it's considered safe. So 17 is not safe, but 12 is safe. So we're going to go with 35 mile per hour recommended advisory speed. And on this, in the southbound direction, they were all less than 12, so they're all safe. We could sign it higher, but to be consistent, we're going to go with 35 miles per hour in both directions. This figure 2C-2 from the OMI TCD, it shows you which signs, a typical sign layout for a curve, and it gives you the references here of helpful tables to help you design your curve layout. So the first thing we need to do is decide which signs we're going to place on our curve. So we look at this table 2C-5. And on 2C-5, for a 35 mile per hour advisory speed, the legal speed is 55, so there's a 25 mile or a 20 mile per hour difference between the two speeds, between the approach speed and the advisory speed. So that tells us that we either need a turn, a curve, a reverse turn, reverse curve, a winding road, the combination horizontal alignment, intersection sign. Those signs are required, whichever one's appropriate for this location. So those signs are found on this chart. This is the advanced turn sign, and this is the advanced curve sign. We usually use the advanced turns for 30 mile per hour or less, and the curves for 35 miles per hour or greater. So since our speed came out to 35, we're going to go with the curve sign for this location. So that sign is required. The advisory speed plaque is required, which is this W13-1P. That's the plaque that's going to go underneath of the advanced curve warning sign. The chevrons are required, which is this W1-8 sign. And then it says required for exit speed and ramp speed, but that's only for an exit ramp, so that doesn't apply in this situation. So now we know what signs we need to order. We need to figure out what size to order, and that's where we look at table 2C-2. So for the horizontal alignment, which is that W1-2, our advanced curve sign, for a single lane conventional road, we want to go with the 30 by 30 inch sign. So on our layout, we'll need one for the northbound direction and one for the southbound direction. So that's where we have here. We have one 30 by 30 right and one 30 by 30 left. And you gotta keep in mind the direction you're going on the curve. It can be a little tricky, but if you're going one way, that's a right sign, and this way is a left sign. So we have our advanced sign ordered, and then for the size of the advisory speed plaque, that's on table 2C-2 also. The advisory speed plaque for a single lane conventional road, we're gonna order the 18 by 18 inch sign. So we need one for the northbound and one for the southbound direction. So we'll order two 35 mile per hour, 18 by 18 inch advisory speed plaques. And then for the chevrons, this third sign that's required, we need to know how many to order. So for our curve, we measured the length of it from Google Maps, and we got the curve length of 450 feet. So 450 feet, and table 2C-6 shows you the typical spacing of chevrons. So for 35 mile per hour advisory speed, you want to space your chevrons at 120 feet. So for a 450 foot curve, you'll need 5 chevrons through the curve at 120 foot spacing. So that's 5 for the northbound direction and 5 for the southbound direction. So we put 10 on here, and then to get the size again, you go to table 2C-2. And for the chevron alignment, conventional single lane is an 18 by 24 inch chevron sign. So these columns are the sizes. So that's why we have 10 there. And then the next thing to order is the signpost reflectors. And here I've kind of drawn out our layout specific for this curve. So we have a 450 foot curve. We've got our 5 chevrons here. We have our advanced curve warning signs with the advisory speed plaques. And one thing I didn't mention yet was, how do you know where to put your advanced warning signs? And that is on table 2C-4, which is right here. So for a 55 mile per hour posted speed, to drop down to 35 isn't on this table, so we go down to the lower number to 30. So from 55 to slow down to go to 30, it tells us that we need 200 feet. So our advanced signs will go 200 feet in advance of the curve. So that's where it starts to curve, the point of curvature. And then the next thing I was getting to was the signpost reflectors. These signs are installed a minimum of 5 feet from the edge of pavement to the bottom of the sign, and then you have the plaque underneath of that. So for these signs, I order the 3-foot sections of the post reflector strips. So we'll need one for this sign and one for this sign. So that's 2 of the 3-foot sections. And then for the 5 chevrons around the curve, the bottom of the sign is 5 feet to the edge of the pavement. So that's where we order the 4-foot sections. And we'll need 10 of those because we have 5 in the northbound direction and 5 in the southbound direction. And then I use this blank space here to write the work order when I send it out to the counties. But that's all there is to filling out your sign order form. And I think Ray has some information on things offered by the LTAP office.
Well, thank you, Jennifer. This information is going to be very helpful to our township trustees across the state and to the county engineers that help them for our township signage upgrade program that we have going on right now. So we're going to be uploading this video to our webpage very shortly, and you can also read further about our LTAP Township Sign Upgrade Program on our webpage. And if you are eligible for that program, we will be notifying you by sending you a letter in the mail. So thank you, Jennifer, for sharing your expertise with us today. And is that all we have? That's all?
Yeah, and I think the local.
Oh yes, we have our LTAP program. You can contact me, Ray Brushart, at LTAP, and we can ship our ball bank indicator out to you, so you can now conduct your own curve study based on the information you saw today and with this piece of equipment. And you can borrow it for a few weeks and send it back to us so that we can share it with other townships. We're actually going to be ordering a few more of these so we have more to share. So be happy to do that for you. So I think we've learned a lot here today, and like I said, visit our webpage and you can watch this video there at any time. So is that it?
I think that's it.
Yes, that's it. So over and out from Ohio LTAP with Ray Brushart and Jennifer Jenkins from District 6, ODOT District 6 Traffic Engineer. Thank you.